In this question, we want to determine the measure of the acute angle. You can see I added the word acute afterwards, between these two lines, rounded to the nearest tenth of a degree. Well, because these are two lines in two dimensions, and because the lines are not parallel, we know that the lines intersect in exactly one point. Now you might wonder, how do we know they're not parallel? Well, they're both in standard form, or what we call Cartesian form. And therefore, a normal vector, in other words, a vector perpendicular to each line, can be given by reading the A and B coefficients and placing them in as components of a vector. So 3, 8 is a vector perpendicular to this first line. We call that the normal, 3, 8. 2, negative 5 is a vector perpendicular to the second line, and we call that a normal. Well, it's a property of lines in two dimensions that the angle between their normals is the angle between the lines themselves at the point of intersection. So we just need to figure out the angle between these two normals. And that is a dot product issue. What we can do is calculate the dot product between these two vectors and know that it equals the magnitude of the first times the magnitude of the second times the cosine of the angle in between them. Well, we're going to calculate the dot product between them by using the component method. 3 times 2 is 6, 8 times negative 5 is negative 40. So 6 minus 40 is the dot product. But the dot product is also the magnitude of the first times the magnitude of the second times the cosine of the angle in between them. Well, the magnitude of the first normal vector is root 73 and the magnitude of the second is root 29. So dividing negative 34 by root 73 root 29 gives us the cosine of the angle in between the two normal vectors. Using our calculators, we see that this number is approximately equal to negative 0.7390. The cos inverse of that is approximately 137.6 degrees. That's an obtuse angle. If we want the acute angle between them, we simply subtract that number from 180 degrees. Now, if you're wondering why can we do that, it's because the two lines intersect like so. And what we've just done is evaluated this angle. And we've said that this angle is 137.6 degrees. Well, there's this angle also. That's the acute one. And it's 180 minus this number. 180 degrees minus 137.6 is 42.4. So therefore, the measure of the acute angle between the lines is approximately 42.4 degrees.